We're going to do some quadratic word problems kind of stuff. A lot of geometry stuff, one ball throwing, and some couple other things. But I wanted to start with a slight little review. Okay, so first of all, what's a parabola? So remember that this, we draw something like this, we have a parabola like that, or a parabola like that. This is concave up and concave down. So either goes up or goes down. Now, an important part of these parabolas are basically the vertices. If it's concave up, it's got a minimum. If it's concave down, it's got a maximum, right? And then it crosses the x-axis, possibly, often with 2 points, but could be no points, and could be exactly 1 point, like so, right? And sort of an important point to keep in mind is, all right, look at my face. You can kind of think of this as a parabola going down. This level is the x-axis. So parabola, here are my roots. Here's my maximum, if it's going down like this, the vertex. And this maximum is halfway between the roots. Okay? It's a line of symmetry, just like our faces are basically symmetrical. Parabolas are symmetrical. Just flip them around each other around the vertex, the line going through the vertex, like so. They flip around, so the roots are halfway in between. Any other constant line is also halfway. So like, like this level, right? These 2 points on the parabola are also symmetrically related to this. It's just going down like that. Okay, and of course the same thing is true for the concave up. Here's the minimum, goes up like this, roots, minimum's halfway in between. Okay, good. So it's really important that the vertex is halfway between roots, or really, if you draw any line, these things always LL, right? Halfway between any two vertical, where the parabola intersects any horizontal line. Those 2 points, the distance along the x-axis of where those points are, from that to the vertex is the same as this to that point. Okay? It's always talking when I say halfway, it's the x location. All right, good. So that's really the visual stuff that you should try to keep in mind. Our tools for investigating these things, we've got GeoGebra. Plug in a parabola, plug in some horizontal lines, click the intersection, boom, you're good. Or the roots button for the parabola for the x-axis intersections, or the extremum button for the vertex. So just plug away, boom, you're good. Also, we'll see in a lot of these geometry problems, you can actually construct the geometrical picture and then play around with the points to actually get to explore the geometry to get the answer that way, and then compare what you did with the quadratic setup. Always good confirmation. This is about giving you the tools to explore. You have some idea, you have some question, explore with GeoGebra, try to set it up, try to solve it. You can use GeoGebra to also solve the quadratic. You can do it manually. You got all these things, right? We've also got calculator stuff. Haven't done too much with that. A little bit more this time, I think. But basically, there's at the current time an iOS app called Graph and Calc 83. That's a great simulation of the TI-83 calculator, or 84, I guess it is, that you know, is typical in K-12 education and is allowed on tests and so forth. So if you're interested in that kind of stuff, you should probably get familiar with the calculator. The app is really great. I mean, it's wonderful. It's anyone who's familiar with the TI-80 stuff will enjoy having that on their phone, and I would actually recommend it. There are some things that it's really good for. And then let's see what else we got. We got also Wolfram Alpha. Basically, type in whatever equation you're trying to solve, hit enter, solves it for you. Gives you the exact stuff if it's available. You can click on the thing to approximate form, boom, you're good. All right. So those are all. Get the computer to solve it. And I put them first because, honestly, a lot of the times if I have access to these things when I have a question or something that seems related to this, I will go to those. I might do some scratch work on my own too. I'm always going to go to those things to make sure. The more ways you try to do something in different ways, they all agree, you're either doing it right or you really misunderstood the starting point. It's rare to make the same mistakes later on. The starting point, though, that's always the question, right? Did you model this thing correctly? There's a certain point at which none of your checks work if you misunderstand the problem. So it's that first point that you always need to just kind of like think about and check, and you know, maybe ask somebody else, see if it makes sense to them. All right, but what are our tools for doing things? We've got the guess and check. So guess an answer. It's going to be wrong. Plug it in. See how close you are. Do another guess. Plug that in. And then see where, you know, whatever you're trying to achieve, where that sits in between the two guesses. And then modify your guess to kind of be there. So like, you know, if I guess something like here, well, let's say I guess at 1 and I get 10. I guess at 3 and I get 20. And I want 14. So what I'm going to do is like, okay, so between 10 and 20 was 10 steps, right? So that's kind of the y values, 10 steps. So the change in y. The change in x was 2, from 1 to 3, right? So if I want 14, I want sort of these 4 steps on the y, and so that's kind of 4/10 of the way, right? So then I want 4/10 of that step size from 1 to 3 too. So it's basically I'm going to add 8/10 to 1. So this is kind of like where 14 is. So that's 4, and that's 6. And so, yeah, sort of like I want to go 4/10. 4/10 of this total length, which is 2. And so that's adding 8/10 there. And if I were going down from 3, that would be 6/10, or so 12/10. 12/10 there. So that's, but anyway, I would try 1.8 next, right? So that's the guess and check with, and it's really well supported in terms of some calculus stuff, in terms of this thing working out pretty darn well. You have to be somewhat close in general for this to work out, but ideally if you're working with a problem you have some idea of the scale. You're going to start with a reasonable guess that's close enough to get the answer. And quadratics are very well behaved, not entirely. If you're guessing close to the vertex, it's going to have some problems because it's almost horizontal. But otherwise, it's a good tool, and we'll see that a few times. There's also the sort of I might call it the completing the square method. So my take on it, and there's a variety of different ways of doing this, but let's say we've got, I don't know, 3x squared plus 5x plus 7, and we want to set it equal to 12. All right? Now, a lot of times you'll want to set it equal to 0, so you'd subtract 12 to the other side. But the technique I have in mind here doesn't matter. You're going to want to, you actually want to do kind of like this. Here it has 3x squared plus 5x equals 5. Put that constant on the other side. So subtract 7 to both sides. Doesn't really matter. So 3x squared plus 5x. So here's my idea. Right, so you have x, 3x plus 5. So you have 0 is one root of this thing. I've got a positive coefficient in front of x squared, so that means it's going up. And 3x plus 5, so if I were to solve that, I get x equals minus 5/3. So this is my other point, minus 5/3. Okay, and then I have a parabola like that, and again, it's halfway between the 2 points, right? So it's minus 5/6 is that point. Good. Now, my claim, and it's true, is that if you write 3x, 3 times the quantity x plus 5/3 squared, and you square it out, you will get the 3x squared plus 5x part, and then there's some other, constant part. Now you can compute that and figure out the different. If you look at completing the square by conventional methods, it's kind of messy. But here's the trick, right? So I know that this thing is at minus 5/6. I also know that the length between here is 5/6, and the length between here is 5/6. This is kind of important to think in terms of the length instead of the midpoint, in case you come across two factors next to each other that are not just having x. You can still do the midpoint. You find where those two things are 0. Take the midpoint there. And then what I'm about to do is the length between the midpoint and that, which is what matters. So if you plug in minus 5/6 into this, well, actually, sorry, into x and x plus 5/3. So I factored out the 3. That's why the 3 is in front of that squared term. Now, when it's in this form, I plug in the midpoint, right? This thing, well, that's just going to be minus 5/6. Now, what is this thing? Minus 5/6 plus 5/3. Well, to do this, I'm going to get common denominators, right? So it's minus 5/6 plus 10/6, or equal to 5/6. That's not a coincidence. That 5/6, remember, it was like halfway from the 5/3, right? It's really, what we're plugging in here is computing the length, the distance from that vertex on the x coordinates to the two roots, right? So it's that point. And then we're end up multiplying them. So it's 5/6. So it's minus 25/36, whatever, some number. And that's what we put here, times 3. So the general idea is if you've got something like this, you got this, let's say that distance is L, then you got the halfway point, and then this thing is going to be minus AL squared. That's it. That's what it is. Because those two factors, it's the length in between the midpoint and so you're multiplying them, so you're squaring it. But there's a minus sign because one's to the left, one's to the right. So you're going to get one that's positive and one that's negative. Good. And then the A just comes in because, that's multiplying everything. right? Okay, good. And then, oops, just, now let's just try to squeeze on the last thing, which is the quadratic formula. Now, I do not like that formula too much. It is handy at times. It's not totally bad. But first of all, you have to get it into this form, ax squared plus bx plus c equals 0. A lot of times, these other methods that I'm proposing saves a lot of work by not worrying about that. It's good. It's good. It's good. Trust me. But you can do that. There's a lot of algebraic manipulations. And then once you do it, it's minus b plus or minus the square root of b squared minus 4ac over 2a. So then you just plug in a lot of numbers. You have to negate the b here. That's tricky. Obviously the plus and minus, and the square root of b squared minus 4ac. That's a lot of computations. And then divide by the 2a. So that's the quadratic formula. We'll use it at times just to show it. I also forgot with the completing the squared part. Once you have the squared form of it, just go back to here. So 3x plus 5 thirds squared minus, so the 3 cancels 25 twelfths equals 5. Now you just solve for the x. You do 5 plus 25 twelfths, divide by 3, or whatever, and then you do x, you square root it. You go through those steps. Obviously this is messy. Most of the time it's messy. Did I mention GeoGebra and Wolfram Alpha in the calculator? Those are good tools. They just give you answers. But anyway, if you want to do this algebraic mess, you can. The main thing to think about is, you have this parabola stuff, 2 roots, vertexes in the middle. You can write a squared form based on that idea. Make sure you understand how to do that. We'll do several examples upcoming. And then once you have that squared form, just solve for the x. Put the extra constant thing on the other side, divide by that coefficient in front of the square thing, that's the a, and then take square root. You have plus or minus, because when you square something, you don't know whether it was positive or negative afterwards. And then you've got x plus something, put that something on the other side, and you're done. Now, a lot of times the plus and minus, giving you 2 solutions. One might only be applicable. Oftentimes that's the case in problems. And again, if you draw the picture, you know which one it's going to be, right? The plus means going to the right. The negative means going to the left. And so when you draw the picture of a parabola, and you see, okay, the thing I'm interested in is over on this side, then you know to do the plus. Also, often if you just compute these things, you get that answer. All right. It's a bit long for an overview, but hopefully makes some sense and leads to a foundation for understanding my techniques for the next upcoming problem.